Okay, I'm looking here at number 21, and essentially this problem right here talks about our centripetal acceleration problems that we had. Real simple one, the movement of an object or a point mass at a constant speed around a circle that has a fixed radius is called uniform. Well, it's not elliptical because it's not going to move in an ellipse. It is rotating, but it's not called rotational motion. It's not parabolic. It's moving in a circle, so it's called circular motion. Okay, we're going to look at number 24 here. Newton's law of universal gravitation states that. Well, let's do a quick review. Newton's universal law of gravitation here was Fg, meaning the force of gravity, equals capital G times m1 m2 over r squared. And capital G in this case was 6.67 times 10 to the negative 11th with a bunch of units after it, but there's the main consistent part of it. So what is it consisting? The orbit of planets are elliptical. The speed of planets' orbit varies depending on which part of the ellipse it is occupying. The square of the ratio of the periods of any two planets revolving around the Sun is equal to the cube of the ratio of their average distance from the Sun. Or objects attract other objects with a force that is directly proportional to the product of their masses and inversely proportional. Yes, it's letter D. All right. Objects attract. We said that any two things that have mass are going to attract each other with a force that is directly proportional. Basically, that means they're going to multiply. All right, the product of their masses. Right here we have their two masses being multiplied. And inversely proportional. Inversely meaning divided by, all right, the square of the distance between them. So that's this equation right here. Okay, number 32. We've gone quite a bit here. Venus orbits the Sun with an orbital radius of 1.0 times 10 to the 11th meters. Given that the mass of the Sun is 2.0 times 10 to the 30th kilograms, calculate the period of Venus's orbit. Well, what this comes down here to is a couple things. They give us the radius that Venus travels around. Because they give us the radius, we can find the circumference. Notice I didn't use an equal sign there. I did say that it's going to give us the circumference. Once we have the circumference, from the circumference, we're going to be able to say that that's the distance, which is equal to velocity times time. And we're going to know the distance then because it's the circumference. We're going to find the velocity here in a second, and that'll help us to find the period, which is the time that it takes to go around, for Venus to go around. Well, how do we do that? Well, we know that what's holding Venus in place? Venus is held in place by gravity. And in this case, gravity is a centripetal force. Venus is heading in a circle, and gravity is what holds it in that circle. So that means we're going to be using our centripetal equation, mv squared over r, and it has to be equal to Newton's universal law of gravity. So that's going to be capital G m1 m2 over r squared. Well, the nice thing here is what's traveling? We're going to say that m2 is Venus. Alright, so it says Venus orbits the Sun. So it's Venus that's traveling in centripetal motion. I'm just going to say arbitrarily that it's m2. Well, that means that m2, we're going to cancel out on both sides. This radius, if I multiply this side by r and this side by r, I find out that that cancels out, and that cancels out one of the two r squareds. So basically I'm left with now 6.67 times 10 to the negative 11th times the mass of the Earth, or mass of the Sun, which in this case is 2.0 times 10 to the 30th, over the radius, which is right here 1.08 times 10 to the 11th. What we find out here then is that the velocity, it's moving 35,145. Well, over here now I got to go back and find the circumference. Circumference equals 2 pi r, 2 times 3.14 times the radius of 1.08 times 10 to the 11th. So this circumference turns out to be 6.8 times 10 to the 11th. So I'm going to write this down here for distance. 6.8 times 10 to the 11th equals what the velocity is 35,145 times t. So what's t going to be equal to? T is equal to a big number. Let me see, it's going to be 1, 2, 3, 4, 5, 6, 7. I'm going to say it's equal to 1.9 times 10. 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th seconds. So that is the period virtually of Venus's orbit. Hey, I think that's enough for review for tonight. I'll catch you guys on the flip side.